For this next segment, I'm going to refer to a handout, possibly two handouts, depending on how long we go on this. I'm going to be referring to the handout called Example Number 1, Calculating Pearson's R. Example Number 1, Calculating Pearson's R. So if you don't have that handout, you might want to hit pause, go get that handout, print it out, or at least have it up on the screen. This is what that handout looks like, Calculating Pearson's R. It's a little bit cumbersome, so I probably won't hold it up too much. I will a couple times. But the first thing this handout asks you to do is consider two distributions of data, two variables that were gathered from the same group of people. Each member of the group provided two pieces of information. Hopefully that's somewhat familiar because we just talked about that back when we were dealing with scatter plots and also introducing Pearson's R. These are the raw data. This first column, I've simply called that column person. That's the person that provided the data. And I've numbered them 1 through 12. So 12 people provided us with information. N equals 12 for this example. If I'm right, yes, N equals 12. Each of those 12 people provided us with two pieces of information. And that information is, they reported for us the hours they spent socializing, as well as the hours that they spend studying. Our X variable is, as you can see from the handout, hours spent socializing, and our Y variable is hours spent studying. And again, each of those 12 people provided us with two pieces of information. So for example, just to make sure we're tracking correctly, person number 9, so go down to person number 9. Person number 9 reported to us that they spend 3 hours socializing and they spend 2 hours studying. That's not a lot of socializing or a lot of studying. Person number 2 reported socializing for 10 hours and studying for 15 hours. Person number 11 reported socializing for 6 hours and studying for 20 hours. That's a lot of studying in a week. So what I want you to really glean from this handout is that we've got 12 people, and each of those 12 people provided us with two pieces of information. Okay? Then, at the bottom of each of these columns of data, hours spent socializing, hours spent studying, you should see the mean for each distribution, each variable, as well as the standard deviation. So for example, for this sample of 12 people, the mean hours socializing is 12.25 hours. The standard deviation, S with a hat sub X, all right, remember, pay attention to subscripts, S with a hat sub X. The standard deviation for the sample for hours spent socializing is 8.357 hours. So for our X variable, hours spent socializing, the mean is 12.25 hours, and the standard deviation, S with a hat sub X, is 8.357 hours. Now, our Y variable, our dependent variable, is hours spent studying, and you can likewise see the mean reported there as well. However, the mean for this variable, because it's the Y variable, the mean for this variable is symbolized with Y with a bar over it, which corresponds with our formula for Pearson's R, which we saw, hopefully you saw in the previous segment. So for these data, the mean is 12.083 hours, and the standard deviation, S with a hat sub Y, S with a hat sub Y, is 5.961 hours. So for our dependent variable, our Y variable, hours spent studying, we have a mean, Y with a bar, mean of 12.083. The mean for our Y variable is 12.083, and the standard deviation, S with a hat sub Y, subscript Y, is 5.961 hours. Now, that's just an introduction to the raw data and the summary statistics that you're going to need, means and standard deviations. In addition, the N is 12. Now, page 2 of this handout should look largely familiar. 12 people, our X variable raw data, our Y variable raw data, mean for our X variable, standard deviation for our X variable, mean for our Y variable, standard deviation for our Y variable, except I've added X times Y right here. Hopefully it's pretty clear how I arrived at that column. All I did was multiply each x by its corresponding y. 7 times 15 is 105. That's person number 1. Person number 3, 24 times 20 is 480. Person number 8, 10 times 10 is 100. Person number 11, 6 times 20 is 120. All right, that's all I did to get that column. That's x times y. Each x times its corresponding y value. Simply multiply it across for each case, each of our 12 cases. Then I simply added all those together. That sum of x times y, which also goes into our formula for Pearson's R, sum of x times y is simply all these products added together. So 105 plus 150 plus 480 plus 100 plus 200 plus 120 plus 50 plus 100 plus 6 plus 600 plus 120 plus 35 is 2066. That's sum of x times y. All right? Page 3. I show you the formula for Pearson's R. It's the exact same formula as before. Sum of x times y divided by n minus mean of x times mean of y divided by standard deviation x times standard deviation y. And then I simply solve. All I gotta do is, I'm turning back to page 2. All I gotta do is plug in the information that I need into the correct places in the formula and then solve accordingly. Be sure you observe orders of operation. That's why we went through that whole math algebra review here, right? But everything in here is something that gets plugged into, everything in this summary section here at the bottom is something that gets plugged into the formula. The mean for your x variable gets plugged into the formula. The mean for the y variable gets plugged into the formula. The standard deviation for the x variable gets plugged into the formula in the denominator. The standard deviation for the y variable gets plugged into the formula in the denominator. Sum of x times y gets plugged in. The only thing that's really missing, and it's not really missing because hopefully it's evident, is that there are 12 people in this analysis, so n equals 12. So going back to page 3, as you can see, I simply plugged in each relevant and necessary piece of information into the formula. So sum of x times y equals 2066, and I explained a little bit ago how we arrived at that. Divided by n is 12. Minus the mean of x, 12.25, we established that early on, times the mean of y, 12.083. Then all that is going to get divided by the denominator, which is the standard deviation for our x variable, 8.357, times our standard deviation for our y variable, 5.961. And then I simply solved. 2066 divided by 12 is 172.167. 12.25 times 12.083 is 148.017. Divided by 49.816. Where did that come from? That's simply the standard deviation for x times standard deviation y. 8.357 times 5.961. Solving, that leaves us with 24.15 divided by 49.816, which gives us an R of 0.485. As I mentioned a little bit ago, analysis, calculation of Pearson's R is going to give us a number, 0.485. So now we need to figure out what does that number mean, and that is what our next segment will cover.